Hey everyone, welcome back. It's Mr. Anderson, and today we're going to look at section 6.1.4 from our CPM Common Core Algebra ebook, and we're going to talk about how we can agree on a line of fit. Last time we were together, we made a line of fit from data, and today we're going to do the exact same thing. But today we're going to use and rely on a little bit more heavily the help of technology and the help that technology provides. And one of the ways that we're going to do so hopefully helps us agree on a line of fit that we can use collaboratively or share across, in the sense that two people doing things away from each other without collaboration could arrive at the same answer. We'll talk about that. Okay. We have section 6.1.4 up, and problem 6-30 is going to pull a little bit at my own personal heartstrings, and it's going to bring me back to the middle to late 90s when the Chicago Bulls were kind of taking the NBA by storm as a dynasty. But the following table shows data for one season of the El Toro professional basketball team. El Toro team member Antonio Kusoc was inadvertently left off the list. Antonio played for 2,103 minutes. We would like to predict how many points he scored in the season. So again, we see the main reason we're doing something like this is for the purposes of prediction. We have all of our data, and the data is data that is Chicago Bulls players. The names have been modified. You can spend some time looking at those to make a make a guess as to who each person is. Might be a little entertaining. Maybe watch The Last Dance on Netflix as you're doing that. But we're not going to go with the resource page. We are going to use the Desmos Etool, because when doing something like this and finding something that we can agree on, we want it to be replicatable and scalable, and the way to do that is to have a degree of exactness that technology offers. So I'm going to go to our ebook, and I'm going to use the e-tool that you would see if you were logged in. So here's problem 6-30, and it says draw a line of best fit and then use it to write the equation that models the relationship between the two, or total points of the season and minutes played. Okay, so here's that e-tool. You guys can click on it. I'm going to do it right here, and it brings up an interactive Desmos space for me, and this is really pretty cool. Over here on the left-hand side, it's got the information, it's got the table, it's got over here it's got minutes played, it's got total points, etc., etc., and it's got if I scroll down, it's got the direction. So it gives me this hint here. Drag the purple points to create a line of best fit. Now remember, we want this to kind of follow the trend of our data, and one of the things that I'm thinking as I'm doing this is I want the data to be approximately split in half. Okay, and this is a much more difficult line to control if I get these purple points really close to each other. If I widen them out like I had them here, it's pretty gosh darn good. And I think I've got a pretty good line there. Maybe I bring it up here just so slightly. We're going to talk about this in just a second here, as many of you are maybe screaming at your computer screens saying, Anderson, you got to talk about that. We definitely do, right? It's a very important thing. But looking pretty gosh darn good. And the beauty of this Desmos e-tool, and it's what we're going to take and write this line of fit for, is I can click on my dots, and when I do so, it gives me the points that those dots are at. Now I'm going to take those, and we're going to go back to the notes here, and we're going to spend just a tiny bit of time writing the equation of this line. So I'm going to go back down here. My points are 150 and 30, and 20, 10, and 820. So here is my reminder to you guys for how we do something like that. So I've got 150 and 30, and it looked like it was 20, 10, and 820. Okay, first thing we need, of course, is the slope, right? So I'm going to go ahead and just find the slope of this thing, y2 minus y1 over x2 minus x1. This is 30, sorry. Okay, 820 minus 30 is 790. And then 2010 minus 150, I believe, is 1860. Now, this is some division I can't do in my head, so I'm just going to grab my handy-dandy 4-function calculator. Well, I'm sorry, this is a graphing calculator. Divided by 1860. And I've got 0.4247. So how about approximately equal to 0.425? And there's my slope. And I think that's going to work out for us pretty well, 0.425. But we still need one thing. We still need that intercept. And the intercept is very, very manageable here. All right, I'm going to go back to, and you could use, I'm drawing a blank here. You could use point slope form if you like. I'm going to use slope intercept form because then it'll be very, very clear. Y equals mx plus b form. All right. Y equals, and I'll put that slope in first, that slope that we just calculated. And now I really get to pick any point to plug in. And the point with the smaller numbers is going to be the nicer of the two. So 30 equals 0.425 times 150 plus b. Now do a little multiplication. 0.425 times 150. Right, that works out to be 30 equals 63.75 plus b. And then finally subtract 63.75 from 30. And I've got b is negative 33.75. Now, this is going to be my line of fit. Y equals 0.425x. And really, if we want to get super technical, I should probably do something like that. But maybe for the sake of the fact that this is a nonlinear algebra class or a 9th grade algebra class, we'll leave that off. All right, 0.425x minus 33.75. Okay, so that's my prediction equation. This is the thing that I'm going to be using to make some of these predictions. And we want to make some predictions for, ultimately, we want to make some predictions for this player. So that's really where we are going. Okay, so we drew the line of fit and then we wrote the equation, and now we're going to go ahead and we're going to talk outliers here. And the outlier, and I'm going to move forward, we're going to use that equation in just a second. The outlier that I kind of already highlighted is this guy right up here. And this is a player, a very famous player, or a what's it called? An alter ego of a very famous player. The 30-90-24-91. That's this guy. This is Scotty Sorden, right? Is the outlier. So I'm just going to make that note here. Scotty Sorden. And an outlier. What is that outlier? What is that point? What does an outlier mean? Well, an outlier is a point that is really, really far away from the other points in our data set. So I've got a data point here in my graph. It's really, really far away from all these other ones. And those things are typically extreme values. And in this case, it is because of the exceptional abilities of that player. Some of you guys might even be saying, Anderson, you know, this one looks like it could be an outlier too. This one looks like it could be an outlier too, right? I'm not as convinced that those things are outliers. The thing that I'm going to leave you guys with, the expectation that I have, is that right now, outliers are going to kind of fail the eye test. That is, if it looks like it fits with our data, we're going to assume it's not an outlier. If it stands out as far as, whoops, and I zoomed way in there. If it stands out as far as this one right here, we're going to say, yep, outlier, okay? As you make it into statistics courses or into courses later in this curricular path, you will have a more concrete rule for that, okay? Next thing we're going to go ahead and do is we're going to use our prediction equation and we're going to calculate the residual of this player. So I made a mistake in a prior video, and I had the residual formula incorrect. Okay, but I'm going to go ahead and write this down in this particular case. The residual formula that we have is going to be the actual, like, observed data minus the predicted data. Okay, and so for that, we need to make a prediction for this player. We need to make a prediction using our equation for Scotty Sorden. And I'm going to go ahead and do this, and we've done this before. You guys have probably seen this. I'm going to go ahead and I'm going to say y equals 0.425x. Now I put a blank in there for x. I'll explain why in a second. Minus 33.75. Okay? And the reason I'm doing that is because I'm going to make a prediction based off this x value for Scotty Sorden. So 3090. All right, and my calculator is really going to help me out here. I can't do this in my head. I'm not going to even pretend to. 3090, 0.425 times 3090 minus 33.75. And my calculator says that is 1,279.5. So my predicted y, right? It's worth noting, and that's why that little accent is on there, that it is a prediction. It's not our actual. And we can go ahead then and we can say the residual for this player is going to be his actual value, his actual number of points scored, 2491 minus 1279.5. Now, one more time, I'm going to rely on a calculator to do this subtraction for me. And this works out to be 1,211.5. Now that is our error. That's how far we were off by. And in Scotty Sorden's case, being off by that many points over a season, yikes! That is that's not good, right? So in that particular instance, our model, we're realizing a flaw in our model for that player. So maybe that causes us to think the linear case is the best case, okay? So technology, there's got to be something a little bit better. And as we grow into our next unit, we're going to learn a little bit more about how technology does this, okay? But before I do that, or before we go that route and talk about this, would a player be more proud of a negative or positive residual? Well, in this case, we would say a positive residual because that means they scored more than was actually predicted of them. Okay, real quick, how many points did Anthony Kusoc make? Well, we're going to go ahead one more time. We're going to use our prediction model. And we were given, and notice I left that X blank, we were given some info about Anthony. 2,103 points at the beginning. All right, so I'm going to go ahead and mark that up here. We're going to do a little bit of math. 2,103, so I got 0.425 times 2103 and then minus 33.75. Again, the goal of doing this is for the purposes of prediction. And so I've got 860.025 or about 860 points. Okay, a couple of discussion items I've got here. I already mentioned what I was thinking as I was making my line of fit. I'm trying to get it to follow the trend of that data and then, of course, split my data in half. There's far more rules when a computer does this, and we'll talk about this as we move into that space. What makes one model better than the other? If we could minimize that error. We saw the error for Scotty Sorden, and we want that to be smaller, okay? How can you numerically describe how close the prediction made by the model is to the actual points? Well, we use the residual to do that, right? The residual is that error value. And then finally, why is thinking about absolute value important in this problem? Because the absolute value, an error above or an error below is still the exact same thing. It's an error, right? I could be off by 20 points on the high end or 20 points on the low end. I'm still off by 20 points. Either way, we want to minimize that, and that's where we're headed. Okay, ladies and gents, I have a tiny bit of review preview for you guys, just a little bit here at the end, 35 to 37. Give these a shot. It'll let us know what kind of questions you have. Thanks for watching. Have a great day.